Hello everyone, today I'm going to be giving an introduction on variables. Now if you're new to algebra or you're just doing a little bit of review right now, your first question that you may run into is what is a variable? And that's a great first place to start when it comes to variable because you need to know what they are before you start dealing with them. And simply, when I think about what a variable is, maybe not textbook definition, but I think of it as a placeholder. This is a placeholder for a value that we don't know yet, but we're going to put the variable, which we'll see as a letter, in that place so we know that's what we're trying to solve for. So keeping that in mind, let's look at some examples and then we can see how a variable can be a very useful tool for math. So say we have 4 plus x. You might think, well, what is x? Well, since we're not saying it equal to anything, x can be anything it wants to be. So let's say x was equal to 1, then we would say 4 plus 1, which equals 5. If it was x equals 3, we would say 4 plus 3, which equals 7. If x was 5, we would say 4 plus 5 equals 7. And all we're doing is we're saying x is equal to something, then instead of writing x, we're writing what we say it was equal to. Now, just showing how this applies to an actual example, if we were to set 4 plus x equal to y instead, or rather wrote it in the standard form, y equals x plus 4, now we can see we have a linear equation. And if you guys aren't sure what a linear equation is, I did just do a video on that, so feel free to watch it. But we can write this out, we can map it, and we know that the intercept is 4, and a slope of 1. And it just goes infinitely over in that direction. And when we see the numbers we're just working with, let's say x equals 1, and we know that y would then equal 5. If we have x equals 3, we know that y equals 7. And if we have x equals 5, we know that y equals 9. So a good example of how variables can actually come into play when we're dealing with them, in that we're not simply just solving equations to solve equations, but there tends to be a purpose behind them. Today, we aren't really dealing with a purpose, but rather we're just trying to solve variables to get comfortable with that process. So a great first place to start at, in my opinion, would be adding and subtracting variables to solve equations. You might not have heard of an equation before. An equation simply has variables, and we're trying to figure out what a variable is, or what it is in this situation. And that'll make more sense as we go. So say we had the equation x plus 6 equals 10. Whenever it comes to algebra, you want to make sure you get the variable or the letter on one side and the numbers or everything else on the other side. So what we can do for addition is subtract by 6 on the left side, subtract by 6 on the right side. And when I'm saying sides, I mean sides of this equation symbol. So we can draw a little bit of a line when you're getting used to these equations for the first time, just to understand what your sides are and where you're working at. So we know that 6 minus 6 goes to 0, so they cancel out, and that leaves us with just x on the left side. 10 minus 6 equals 4. So we say that x equals 4. Now we can check this by plugging that back into the variable. So we're saying that x equals 4, and we had x plus 6 equals 10 to start with. So let's say that in this situation, x equals 4 instead. 4 plus 6 equals 10, and that's a true statement, meaning that we solved the equation correctly. Let's look at another example here. Say that rather than what we just had, we had something like x plus 2 equals 5. We can look at that, separate sides here. Subtract 2 from the left, 2 from the right. These 2's cancel out. Then we have x equals 5 minus 2, which is 3. Plug that bad boy back in to see if that's correct. 3 plus 2 equals 5, and you'll see that's a true statement, meaning that we solved the equation correctly. Now say rather than addition, we wanted to work with subtraction, and we had something like x minus 3 equals 7. We can still take this side by side so we know we're solving correctly. But instead of adding by 3, well, instead of subtracting by 3, we're going to add by 3 because now we're dealing with a negative number and we want it to be 0. So we know that negative 3 plus 3 equals 0. So that'll get rid of the number on the left side. You do it to one side, do it to the other. We have just x left on the left side because negative 3 and 3 cancel out. And we'll set that equal to 7 plus 3, which is 10. Plug it back in to see if that's correct. X equals 10 minus 3 equals 7, and that's a true statement, meaning that we solved that equation correctly. Say we had another example over here, but instead of what we just had, we had x minus 5 maybe equals something like 10. Okay, we know that we should probably undo this negative number on the left side, so we have the variable alone. To undo negative 5, you're going to be adding by 5. If you do it to one side, you do it to the other. And that's going to leave us with just x on the left side as these cancel out. Set that equal to 10 plus 5, which would be 15. Let's plug that back in just to see if it's correct. So we had x minus 5 equals 10. Now x equals 15 according to us. Plug that in, and we'll see 15 minus 5 equals 10. That's a true statement, meaning that we solved that correctly. So now that we've looked at some basic addition and subtraction, let's go over to multiplication and division. So multiplication and division are going to be a little more complicated. However, if you do a couple examples, it will seem like it becomes a little easier over time. So first, looking at multiplication, say we have something like 2x equals 10. Now, if you're reviewing or you haven't done algebra before, you might see this number next to the letter or the variable and be confused as there's no interaction, no operation going on between them. But when it comes to algebra, this is a shorthand of writing 2 times x, and it would set that equal to 10. So if you have a number by a variable, all this simply means is that you're multiplying those two. So when it comes to multiplication, to undo multiplication, we divide. We see 2 times x equals 10. So we want x just to be 1 because x equals 1 times x. You could rewrite it. So to undo this 2 and make this equal 1 right here, we can divide this left side by 2. And if you do it to one side, you do it to the other. 2 times x equals 10. Divide both sides by 2. This left side will just be x left over. And then 10 divided by 2 is 5. Plug that in, see if it's correct. 2 times 5 equals 10. That's correct. Whenever you're multiplying a variable, if you plug it back in, you might decide to write it as in parentheses. So 2 parentheses 5 equals 10. It says the same exact thing, and you might see this more often. So just get comfortable with seeing it in that method. Let's go on to another multiplication example. Say we have 5x equals 15. We can write this as 5 times x equals 15. And then divide the left side by 5 to make that 5 a 1. So you'd be left with 1x, or rather just x, equals 15 over 5. And that's going to be 3. Let's plug that in. 5 times 3 equals 15. And we know that that is a correct statement. So we solved that equation correctly. Now that we're done with multiplication, let's look at doing some division problems. Say we had something like 1 over 2x equals 4. Now when looking at this, we knew that for multiplication, we had to do division to undo it. For division, it's opposite. We're going to do multiplication. So we know that we want a 1 over 1 in front of our x, or rather, since it's a 2 on the bottom, that we want 2 over 2. So you can multiply it by 2. And I'll write this in blue just so you can see it a little better in this example. So after multiplying the left by 2, you'd have 2 over 2x equals 4 times 2. That would be 8. And that this just becomes 1. And when you have 1 multiplied by something, it's just the thing by itself. So x equals 8. Now let's plug that back into the original equation just to see if it holds up. Okay. They made me write 8 there. I meant to write 4. So 1 over 2 times 8 is also the same thing as saying 8 divided by 2. That would be 4. and 4 in fact does equal 4, so that's a correct statement, meaning we solved the equation correctly. Let's look at another example quick for division. 1 over 4x equals 3. We won't go so specific like the last one, but rather we're just going to multiply by 4 because we have a 4 in the denominator here. What you do to one side, you do to the other side. We're going to have x left over on this left, 3 times 4 on the right, and that's 12. Let's plug that into the equation just to see if that is correct. Okay, 1 over 4 times 12 is the same thing as saying 12 divided by 4, which comes out to 3. And 3 equals 3 is a true statement, meaning that we solved that equation correctly as well. So now that we've gone through the basics, let's get a little more complicated looking at the future examples. So you might see addition, subtraction, multiplication, division by themselves, but the confusing part of algebra is when you have a lot going on in the same equation and you have to figure out what's the best way of solving it. And I'd say that I can walk you through it and show you, but truly the best way of learning how to solve an equation is practice. So I'm going to give you a couple to practice with. You can do them when I write them and then see if your answer lines up with mine, or we can just walk through them together. So let's look at this first example. We're going to have 2x plus 22 equals x plus 1. Right away we have something different here. We have variables on both sides of the equation and we're working with a little more than just one thing on each side. So no worries when it comes to that. We know that we can subtract, add, multiply, divide numbers when it comes to both sides, but you can also do that with variables because in the end a variable will simply be a number that we're solving for. So looking at this one, we know that division probably wouldn't be the best because then you're dividing two sides of the equations that have multiple numbers by the same thing. It's going to get a little complicated. Rather, what I would propose for this one would be get rid of this x on the right side over here, so we can get x on one side of the equation, which typically is our goal when it comes to algebra. So keeping that in mind, let's just subtract by x to both sides, just to get the x away from this right side here. 2x minus x would be x. We still have 22 on the left side. We're going to be getting rid of this x here. We know that that cancels out. And that leaves us with a 1 on the right side. Now we can say minus 22 to both sides to get rid of that 22. Leaves us with an x on the left side. 1 minus 22 would be negative 21. And that would be our answer. You can plug it in to check. However, I know that's correct. So we're going to avoid just proving that's correct and going on to the next problem. Let's say we have a little bit of a division problem here. X over 3 or x divided by 3 plus 1 equals 6. What I'd recommend here first would be to get this 1 out of the problem, put it onto the other side. So to get this 1 to 0, we subtract by 1. Do it to one side, you do it to the other side. So it leaves us with an x over 3 on this left side, 6 minus 1 on the right, which is 5. And we know that to get rid of 3 in the denominator, that we multiply by 3. So let's do that to both sides. X over 3 times 3 would be x. 5 times 3 would be 15. Let's look at another example over here on the right. Say we had something like x plus 1 equals 4x plus 2. Okay, we know that we should probably look towards getting the x to one side, so let's do that. Let's do minus x minus x, so that will cancel on the left, leaving us with just a 1 on the left. 4x minus x would be 3x, and we still have this 2 left over, so plus 2. And we want the x on one side, everything else on the other. So let's subtract this 2 from both sides and get it away from the right side and just leave that 3x. We know that 1 minus 2 would be negative 1. And we only want 1x, we don't want 3x. So to get rid of this front and make it into a 1, divide that by 3. Do it to the right, do it to the left. So then we can say that negative 1 over 3 equals x. I typically like to write the variables on the left side, which means that x equals negative 1 over 3. You can write it backwards, it means the same exact thing. And for the fourth example, I'm going to give us a bit of a tricky one. It might take multiple steps, but ties in a lot of things together and introduces a new property. Let's look at 2 times parentheses x plus 3 equals x plus 4 all divided by 2. Alright, so looking at this, it might be a little confusing at first. You might think, where should I start? What I would recommend first would to distribute this 2 right here into the parentheses. So what I mean by distribute is that we know that we're looking at 2 times parentheses x plus 3. And when doing that, you're going to be multiplying it to each part that's inside of the parentheses. So what that's going to look like after we do that first step is 2x, 2 times x, plus 6, which is 3 times 2. And we're not doing anything to the right because we didn't change the equation. We just looked at simplifying it with what we already had. And now looking at that, we probably want this fraction to get out of here on the right side. So we know that when we're looking at divided by 2 on the bottom, you should probably multiply by 2 to get rid of that. So we're going to multiply each side of this equation by 2. Okay, so we know that 2 times 2x will be 4x. 2 times 6 would be 12, so 4x plus 12. Notice how we're retaining that addition symbol there. And we know that we're just getting rid of this denominator on the right side, leaving the numerator, which is x plus 4. And now we're looking at a lot easier of a problem to solve. Let's just go by the last couple of steps here. We know that we want x on one side, so let's subtract x to get rid of it from the right side. Now we're going to have 3x plus 12 equals 4, as these x's right here canceled out. And now we want x on one side, everything else on the other side. So let's get rid of this 12 on the left side by subtracting. And now we're going to have just 3x on the left side and negative 8 on the right. Let's rewrite that up here, continue it. 3x equals negative 8. Now we don't want 3x, rather we want just 1x, so we know what x would be. And to do that, you're going to want a 1 in front of the x, so divide by 3. Let's see what this looks like. We'll get that canceling out. X equals negative 8 over 3. And that would be our final answer. Now I'm not going to plug that back in as that gets a little complicated, but if you did, you would see that both sides equal each other, making them a true statement, saying that we solved the equation correctly. Now as you go through algebra, you're going to see more difficult problems, more graphs represented by variables, but having this foundation will make problems a lot easier to solve in the future. So I recommend going through the video again just to get that practice. Thank you all for watching. Make sure you like, subscribe, share with your friends, share with your teachers, and I'll hope to see you guys in the next video. Thank you.